Hey guys, Mr. Backwork here. In this video, we're going to look at functions as graphs. So when we talk about functions, we deal with input values and we deal with output values. Now, as we're looking at these graphs, we're going to take those input and output values and we're going to focus on them as x and y ordered pairs that we're going to be able to plot out on some coordinate grid so that we can look at a picture. So in this example, we're going to graph the function y equals 1/2 x. We're going to use domain values of 0, 2, 4, 6, and 8. And we're going to start by making ourselves a table. So the domain values, remember, those are the x values that we're going to plug in. So we're going to plug in 0, 2, 4, 6, and 8. And we're supposed to plug those values in for the x in our equation. So I'm going to start with 0. I'm going to plug in 0 for my x right here. So if I take 1/2 times 0, well, half of 0 is 0. Then we're going to plug in our next x value of 2. So I'm going to replace the x with a 2. Half times 2, or half of 2, is 1. Then I'm going to plug in my 4 for the x value. Half of 4 is 2. Then I'm going to plug in 6 for that x value. Half of 6 is 3. And then our last x value that we're supposed to plug in is 8. And half of 8 is 4. Now, this table is really giving me a bunch of x and y ordered pairs that I can take and plot out on my coordinate grid. So remember, this horizontal axis is your x-axis. This vertical axis, that's your y-axis. The x values tell you how far you go left or right, and the y values tell you how far you're going up or down. So this first set of values, 0, 0, means I go left or right 0, and then up 0. So that's going to be this point right here where our two axes meet up. And that point 0, 0 is called the origin. Now if I look at my next set of values, we have an x value of 2 and a y value of 1. So we go to the right 2 spaces and then up 1. So right 2 spaces, up 1, there's my next dot. Our next set of values is 4, 2. So I go to the right 4 and up 2. So 1, 2, 3, 4, and then up 2 spaces. My next set of values is 6, 3. So I'm going to the right 6 and up 3. And then my last set of values is 8, 4. So I'm going to the right 8 spaces and up 4 spaces. So those points start to give me a graph of what this function is going to look like visually. Now in this next example, we're going to look at SAT scores, and we're going to look at scores from 1997 to 2003. We're going to let t equal 0 represent the time since 1997, and that's going to be in years, and s is going to represent the average score. Now what we're going to do in here is we're going to choose a scale that we're going to use on our graph. Then we're going to go through and do some labeling with our axes, and then finally at the end, once we get that stuff taken care of, we'll plot out all of our points. So if we look at the t values first, that's going to be this horizontal axis because that's my independent variable. We're going from 0 up to 6. So I think using a scale of 1 there would be pretty appropriate. So I'm going to label that t-axis. So at 0, we're right here. Then we've got 1, 2, 3, 4, 5, and 6. Now, if I look at those s values, those are some pretty big numbers. So I can't count by ones because that's going to take me forever to get up to 511. So the very first thing I need to do is skip a whole bunch of values. And we can show that by doing a little squiggly line on our axis. That means that we're skipping a whole bunch of values. Now, my first s value, or my lowest s value, is 511. So I'm going to put that on this first line here after my squiggly line. Now I need to get up to 519, so I'm going to check to see if I can get there counting by ones. So this would be 511, 512, 13, 14, 15, 16, 17, 18. So that doesn't get me up high enough. So I can't just count by ones. So I think what I'm going to have to do is count by twos. So this next line would be 513. Then I would have 515. Then I would have 517. And then I would have 519. And then I'm going to go one more to 521. Now we've got some even numbered values in here, so when we plot those out, we're just going to have to plot them out halfway between our numbers. So my first point is supposed to be at 0 and then 511. So 0 is going to be back here, and then this first point is supposed to be up at 511. So I'm going to put a dot right there at where that point would be. Then for a t-value of 1, we're supposed to be up at 512. So we go over 1 on the t-axis. We're supposed to go up to 512. But remember, we were counting by 2's, so we have to go halfway in between here. For that t-value of 2, we dropped back down to 511. So I'm going to put a dot right there. For the t-value of 3, we went up to 514. So I need to go halfway between 513 and 515. For my t-value of 4, we stayed at 514, so another point right there. For our t-value of 5, we jumped up to 516, so halfway between 515 and 517. And then lastly, that t-value of 6, we were up at 519. So that set of data points represents our function. In this next example, we're going to write a rule for the function that's represented by the graph. And then we're going to identify the domain and the range. So the very first thing I want to do is look at the graph, but turn that into a table of values. So in order to do that, I need to figure out where these ordered pairs are located. So this first point, we went over 1 space and then up 2. So our x value is 1, our y value is 2. For this next point, we're over 2 and then up 3. So 2, 3. For my next one, we're over 3 spaces and up 4 spaces. For the next one, we're over 4 spaces and up 5. And then our last ordered pair is over 5 spaces and up 6 spaces. So that's our table of values that we're going to work with as we're trying to write our rule for this function. Now the next thing we're going to do is look at our table of values and see if we can identify a relationship between the input and output values. So this first set of values, we started at 1, but then we ended up at 2. Then we went from 2 to 3, 3 to 4, 4 to 5, 5 to 6. So it looks like we're just adding 1 to each one of those input values to get our output value. So once we have that relationship figured out, we're going to go through and we're going to write the function. So in order to get our y value answers, what it looks like we're doing is taking whatever that x input value is and then adding 1 to it. Now we did say that we wanted to identify the domain and the range for this function. So remember, your domain is your input values or your x values. So that's the numbers 1, 2, 3, 4, and 5. And your range, those are your output values or your y values. So that's 2, 3, 4, 5, and 6. Now we're going to do one more example here where we write a rule based on the graph and then identify the domain and the range. So we're going to start by making that table of values again. So we're going to look at all of our ordered pairs. So my first point, we've got an x value of 0 and a y value of 5. So that's 0, 5. Then we've got an x value of 1 and a y value of 4. Then we've got an x value of 2 and a y value of 3. Then we've got an x value of 3 and a y value of 2. And then lastly, we've got an x value of 4 and a y value of 1. Now we're going to try to find a relationship between our input values and our output values, but this one might be a little bit trickier. This time, if we look at our input values and we think about how we move from 0 up to 5, it looks like maybe we're adding 5 each time. But if we test that out on our second set of values, that's not going to work because 1 plus 5 doesn't give me 4. It would give me 6 as an answer. And if I test that out further down the line, it also doesn't work for those other values. So we're going to have to look at this a little bit different. But what I think we can look at it as is if we start at 5 but then take away whatever the x value is, then I think that'll give us the y value. Because if we start at 5 and take away 0, we still get 5 as an answer. But if we start at 5 and take away 1, we get 4. Then if we start with 5, take away 2, we get 3. So as we're testing this out, it looks like it's working. So as far as writing the function, in order to get our y values, we said we were going to start with a value of 5, but then subtract away whatever that x value was. Now we're still going to talk about the domain and the range of this function. So remember, the domain deals with the input values or the x values. So here we've got 0, 1, 2, 3, and 4. And then for our range, remember those are the output values or the y values. So that's 5, 4, 3, 2, and 1. That's going to be it for this video. Thanks for watching.